Hi everyone, it's really great to be here with you today. My name's Andra Christie and I'm a Senior Solutions Architect in the public sector at AWS. So today's session will primarily be led by one of our customers, University of Melbourne's Mark Morris, and he'll take you through their university smart campus and digital twin. I'm going to let Mark talk through the details of everything they achieved, but the aim of this session is for him to share their story and for you to learn how you can leverage AWS solutions and capabilities in order to build your own best-in-class customer experiences in smart cities. Okay, so the agenda will firstly focus on the drive towards improving customer experience and sustainability in smart cities and the technologies that enable that drive, followed by, as I said, the University of Melbourne's deep dive into their smart campus and digital twin, and finally, some lessons learned and what you can do to implement similar projects. So by 2045, the world's urban population will actually increase by 1.5 times. And in order to be able to efficiently implement the many customer experience and sustainability initiatives for now and into the future, many technologies have been enabled by cloud computing, and they're driving transformations in lots of areas, including AI/ML, data lakes, open data, augmented reality, digital twins, and a lot more. Some of these technologies have actually been around for a really long time, but what makes them really relevant now is we've got customers across industries focusing on digital transformation. They're using more advanced technologies like graph databases or immersive visualizations. There's a much broader adoption of IoT and machine learning. And obviously, cloud computing in general has made use of these solutions not just possible, but within reach for all of our customers. I got involved with looking at digital twin and smart cities a few years ago, and that led to going to a lot of events, to meeting people and innovators who are actually building these solutions. They might have been building solutions around water management, energy management, transport, waste, all of these domains. And invariably, they were using cloud computing, and many of them were actually using AWS. And yet there was this feeling that they were all isolated solutions. So if you look at the diagram on the screen, you can see all of the blue circles essentially being disparate solutions. So that's what we were seeing in the market. But then we would go and speak to local governments or to facilities managers, people essentially responsible for places. But what they really wanted was data and insights. And there was this desire to actually create a platform and bring all of these disparate solutions together. And this is what we decided to focus on solving at AWS, to create a platform that basically provides a holistic answer to the questions that were being asked in the smart city solutions area. I'll go into that a bit later, but suffice to say that when we're successful together and working in a holistic way, it lets us make better decisions faster. It allows us to respond to the unexpected, to create better citizen experiences, to uncover opportunities, to improve efficiency, which is of course great for the taxpayer as well. Another big focus area for us is around sustainability. So, for example, did you know that 30% of the energy consumed by the average building goes to waste? That's a huge number, especially if you extrapolate that to the number of buildings in a university smart campus and then further out into a single modern city. Surely there are things that we can do better and more efficiently and more sustainably. As we know, sustainability touches everyone and multiple sectors of society, many areas of the economy, to how we decarbonize our business operations, water conservation, and even responsible employment. More cities are recognizing the value of prioritizing sustainability development across all of their activities and projects. Finally, digital twins are also gaining more popularity in building those best-in-class customer experiences for smart cities. And this includes everything from better event management, urban planning, energy reduction initiatives, and sustainable outcomes. There are a lot of interpretations out there, but simply put, digital twins are virtual representations of physical objects or processes that very closely mimic the state and behavior of the physical counterpart, but more importantly, they're built to solve specific business challenges. We're seeing more and more customers who are using digital twins to get a better visibility into their operations, to get a deeper understanding about their environments, and to look for ways to improve and bring improvements to users and citizens alike. And with that, I'd like to invite Mike Morris to talk you through the University of Melbourne's Smart Campus and Digital Twin solution. Thanks, Mike.
Thanks, Andra. Thanks, Andra, and thank you to AWS for giving me the opportunity to come and speak to you today, and also thank you all for coming to a late session in the day and staying back to hear what we have had to say. So I'm Mark Morris. I'm the Product Manager for the University of Melbourne Smart Campus program, and over the past 3 or 4 years, the university has invested a significant amount of time and money into building its Smart Campus platform. And the platform's intended to work across 4 different focus areas at the university. So that's 1, our operations, so how we run our campuses. 2, how we plan our campuses. 3, how our students and staff experience the campus. And then underpinning all those initiatives is how we build a sustainable campus and work towards our 2030 goals. The platform itself is operational in terms of its position. It's intended to be more of an operational intelligence platform as a distinct discipline from business intelligence, which is done in a different part of the university. And so we work very closely, for example, with our facilities people and those people involved at the university in terms of day-to-day operations. It's predicated on IoT and bringing in a lot of sensor data. So we have a range of different sensor data that we bring in to the platform, from occupancy sensors to space comfort sensors to electricity meters to building management systems. And they're all brought in to our data lake, which we've built and designed and architected in partnership with AWS. And then we have a range of outputs that platform can produce, and a range of audiences too for the different outputs that we produce. So we do have a very diverse range of users, and we need to cater for people across a wide spectrum. So from people who might just want a chart to embed on their faculty website, all the way through to power users who might want to do some very sophisticated data analysis, as well as supporting some of our researchers in terms of their needs around data acquisition and data processing. We have 2 methods by which people can interact with the Smart Campus platform. So we have our Campus Now application, which is a web app that we've developed ourselves in-house. And that's more of a real-time view of campus, and it's map-based and allows people to sort of interrogate the campus and what's going on right now. And then we provide a number of dashboards and historical data through AWS's QuickSight platform. So if you're familiar with, say, Power BI or Tableau, it's quite similar and offers quite a lot of functionality, but with the advantage that it integrates very seamlessly with our data lake and the infrastructure that we've built around Smart Campus. So now I'm going to take you through a couple of use cases that we've developed and worked through over the last couple of years. The first one relates to campus planning. The University of Melbourne, as you can imagine, is a very big organisation. We have about close to 500 buildings in our property portfolio across 6 different campuses. And so planning the campus and managing the campus is obviously quite challenging. And so we've put in place an initiative to better understand how people are using the spaces across campus, particularly post-COVID, where there is perhaps less people coming to campus and there are questions being asked about, all the space that we need to maintain. And we did this by bringing in a range of different data points from sources around the campus. So we bring in Wi-Fi analytics from our Cisco Wi-Fi system. We take door swipe data. As I said, we've got occupancy sensors in a number of places around campus. We have meeting rooms fitted with occupancy counters as well. And that all goes into the data lake. But the most important part of it is that we also bring in data that allows us to contextualize those sensor data. So we bring in space information from our Archibus system, which tells us about, is this a teaching space or is this a learning, a library? We bring in class timetabling and class registration data, so we know what subjects are being taught in a particular space and what people and the number of people that should be there based on the registrations. And by combining that data together, it allows us to really ask a lot of questions that previously we couldn't do. So these are just some of the visualizations that we do through Campus Now. So a bit of building information. The one in the middle is to do with some real-time occupancy. We do some forecast modelling as well. So for some of the more popular areas on campus, we'll provide students with a forecast of when the busy times are going to be to help them better plan their visits and their time at our campuses. This is quite an interesting graph. So what this shows is a number of different data points that we bring in. So starting with sort of the top yellow line up here, this is what we think the number of people who are going to sign up for a particular subject. And then the one below in the green is that the actual number of people who did end up signing up for a subject and registering the subject. And then the yellow line right down the bottom there, that's actually the number of people who physically came and sat in the room and took that subject. Then it's a little bit hard to see, but we've got some pink lines that run, vertical lines, and that actually denotes the different subjects. So across the course of a day for a particular space, we can look at the number of people who are attending versus the number of people who were supposed to be attending. We can look at what classes, what subjects, and begin to work with the timetabling people and the faculties to address issues where there is the inappropriate or inefficient allocation of space to a particular subject. So as I said, this one, it's allowed us to be more efficient in the way we use our spaces. It's allowed us to ask questions about, are our spaces meeting the diverse needs of our students? We can look at things such as data-driven maintenance, where we understand foot traffic and we understand the usage of spaces, and allows us to better plan our maintenance activities. And most importantly, we now have evidence-based capital investments. So when we put forward a proposal to build a new lab or a new building or a new library, we have the evidence based on patronage to be able to justify, what is a very significant spend for the university. So COVID obviously changed our lives fundamentally forever, and the university was impacted and was closed for a period of time. And so when it came time to open up again, it was very important for us to be able to demonstrate to our students that it was a safe learning environment to return to. And so we initiated a project to measure air quality and, more importantly, air turnover in our teaching and learning spaces, so that we could give confidence that we were minimising as much as we can the risk of airborne pathogens being passed between people. And so it was a very interesting initiative because it involved some of our facilities folk working with academics to actually try and work out, what is the best ventilation practices that we can implement in order to reduce the risk of the transmission of things like COVID. We also developed a contract tracing application way before the Victorian government, QR code based, that allowed us to do contact tracing very early on. And then operationally, we were able to produce a report that could highlight areas where air turnover wasn't what it should be, and then allow our facilities people to very quickly respond and take action to then, put in purifiers or increase the amount of fresh air exchange. And again, it was the same sort of thing where we had multiple data sets that we brought into the data lake, and we then performed the analytics. This was an interesting one as well, because as part of it, we built a LoRaWAN network at the university, so a low-powered wireless network that allowed us to deploy thousands of sensors at scale in a way that's very cost-effective and provides data in a real-time fashion. So we built the LoRaWAN network in partnership with Meshed, and the devices return CO2, temperature, humidity, light, and motion. But the one we're interested in is CO2, and we use that as a proxy for air turnover. So by monitoring the levels of CO2 in our teaching and learning spaces, we can ascertain whether or not the ventilation is adequate and then intervene where we need to. So we've got about 850 spaces covered at the university, just on 2,000 sensors deployed, and actively all feeding into our data lake. And then to complement that, we also brought in data from our building management system, because our building management system also had CO2 sensors in many spaces as well that we could leverage. And so we have an enterprise integration platform, Dell Boomi, and by connecting our building management system to Boomi, we were then able to take that building management data into the data lake as well and make that part of the overall solution. So again, some screenshots from our Campus Now application. So on the left-hand side there, that allowed people to drill into a particular space on the campus and actually check the CO2 levels in that space on campus. and then down the bottom there is sort of the feed that our campus or our facilities people would get in terms of the different spaces and what state they are in. So again, another interesting piece of work, multidisciplinary in terms of staff, facilities, IT, academics. We managed to get the QR code out and implement contact tracing very quickly. We had proactive air quality interventions in our teaching learning spaces, and that we could provide quantitative evidence back to the student community that we were doing everything in our power to make sure that our teaching and learning spaces were safe for them to come back to. So energy at the university, as you can imagine, it's a multi-million-dollar line item in our budget, very, very significant spend each year, and also has attached to it a very large carbon footprint as well. So there's a lot of interest in trying to minimise and make more efficient the way we use energy. And so as part of Smart Campus, we've developed a forecasting model to help forecast energy demand across the university. And so in this one, it takes in, again, multiple data points. So we have an integration with our billing provider who provides billing information in the form of PDF files. That's brought through our enterprise integration platform and eventually makes it into the lake. We pull in a few other bits and pieces, and we're able to produce both a long-term and a short-term forecast across our different campuses, and then provide information as well in terms of usage reports around both financial and sustainability. And so some more charts there. So again, we were able to contextualize our data, our energy data, in ways that weren't previously possible by putting it all into the lake. We had an expedited visibility of the consumption and the costs, improved budgeting of a multi-million-dollar spend, and it also helped inform our campus management folk around where there are opportunities to intervene from a sustainability point of view based on different measures of energy intensity. So, and to that end, this is two charts that have a look at different measures of energy intensity. So the scatter plot there on the left shows energy usage by building versus gross floor area. And so that allowed us to identify different outliers in terms of their energy intensity and energy footprint. And then the one below is sort of energy usage by occupancy. So number of people in the building on a particular day versus energy consumption in that building on that particular day. And again, another way that we can quantify energy intensity and better understand where we might need to take action or where there are opportunities to intervene in these buildings and take remedial action. Now, one of the other tenets of Smart Campus is that we are a research institution, and these data sets may have value for things beyond just operational intelligence. And so we wanted to ensure that we maximise the way that we could make this data accessible to the university community. And that meant using open data standards. So we embraced, wherever we can, open standards in terms of the way we store our data. The LoRa WAN network that we built, it's an open network, so students and staff and the community around Parkfield can actually connect to it and use it for their own ends. We have standard APIs that we published and integrations to further enhance open access. And it can also double as a teaching tool. So it is open to our faculties to integrate the concept of a smart campus as well as the data that we collect into their curriculum and their particular subjects. But overarching that is obviously governance. So governance is very important. And so we work to the principle of least privilege so that ensuring that, you only have access to what is absolutely required. So now I'm going to take a couple of minutes just to walk you through the supporting infrastructure. And as I said, we've made extensive use of services from Amazon to build this lake. And I think coming on board as the product manager last year, I was flabbergasted at just how cost-effective this platform is to run. We were very fortunate that early on we had the involvement of Amazon to actually develop the architecture that supports it, and it was done in a way that meant we could deliver this at scale, but at a very cost-effective price or operational cost. So in terms of our technology stack, we have our acquisition layer on the left there where we have our data producers, so predominantly sensor data, but we do have a lot of system integrations. We use IoT Core extensively to terminate sensor data from our LoRa WAN network and other sensor endpoints. Firehose is used in terms of our data processing pipelines. The lake is built on S3, so a very cost-effective way to build your data lake. We store our files in what's called a Parquet format, so it's all file-based, and Parquet is a file format that's optimized to work with Athena, which I'll talk to in a moment. We use warm storage, so we have DynamoDB as our warm storage, which serves data out to our API endpoints and to the API endpoints supporting our Campus Now application. And as I said, we use Athena. So Athena is a magical product from Amazon that allows us to run standard SQL queries across our file-based data lake, our unstructured file-based data lake. And so it really makes it quite powerful for us in terms of being able to leverage the data in that data lake. And as I mentioned before, we also use QuickSight for our dashboards and some of our visualizations. To drop down one level below, this is sort of the high-level architecture that supports us. So as I said, predominantly IoT core on the left-hand side, terminating those connections from our sensor network. We run a number of data processing pipelines, which are made up of Kinesis Firehose and chained Lambda functions that do our extraction, transformation, and loading. They're brought into the data lake, and then we have a number of different step functions that then may transform that data once more and put it in the correct bucket depending on its end use and end purpose. To the lower part, we also have data that's carved off and sent to Dynamo, so that's structured data into the DynamoDB, which then allows us to serve that out via our API endpoints. So if we reflect on what we've achieved over the last couple of years, as an organization, by developing the data lake and the analytics that sit over it and the visualizations, we're able to interrogate data from new and exciting perspectives in ways that were just not possible beforehand. For our infrastructure managers and owners, they're able to apply evidence-based decision-making in terms of the way they maintain and optimize the different assets under their control. As a researcher, I can come to the Smart Campus team and consume a service such as telemetry as a service from us, so I can concentrate on my core research and not be worrying about LoRaWAN gateways and API keys and all the rest of it. We can get that all going for you. And then as a student, I'm able to access real-time data about the health and state of my campus, and I can plan and act accordingly depending on what that tells us. So I hope that's been informative for you all in terms of our journey with AWS in developing our Smart Campus, and I'll pass back to Andra.
Thank you, Mark. Thank you so much for sharing your story. That was a really great example, I think, of what's possible and achievable for anyone who's looking to improve customer experiences through smart cities and digital twin solutions. I mentioned earlier that we wanted to create a platform that really gives that holistic answer to the questions that we're being asked in the smart city solutions arena. And AWS Smart City Competency is something that can help you choose the right partner to help you build a similar solution to what University of Melbourne have built, obviously to suit your specific use case. We've got a lot of AWS partners who are leveraging the power of AWS Cloud to innovate and deploy meaningful smart city solutions in many areas, including urban data platforms that help smart cities gain insights for data-driven decision-making. It's all about improving efficiency and delivery of urban infrastructure, whether that's water, waste, transport, energy, and most importantly, it focuses on delivering solutions and better government services to all urban citizens. Also, in order to help customers with their digital twin initiatives, AWS have also released a digital twin builder solution called AWS IoT Twin Maker. So it's essentially a service that's meant to help customers easily create digital twins of real-world systems and then use them to optimize operations, increase safety and productivity, and improve customer experiences and outcomes. So as I mentioned at the very beginning, by 2045, the world's urban population is going to increase by 1.5 times. So we really need to consider how we can help build those innovative, inclusive, and sustainable cities for the future. So if you're in the audience and you don't happen to have a smart city, which is probably most of you, you can always start small with the right idea and the right use case. You can get your IoT sensors and other useful data sources, and you can build your own best-in-class customer experience, even if it's for a small number of customers. The point is to get started today. Thanks again for your time today. We really hope that you've enjoyed the session and picked up some valuable tips around the technology, the solutions, as well as the partners that are available to help you build similar solutions in your own organizations. Please don't forget to fill out the session survey. I think Mark's going to run off because he's got a flight to catch, but I'll be around if you've got some other questions. So really appreciate your time and hope that's been useful to you. Thanks again.